Greetings everyone. Well, welcome to our channel, College Course Solutions Mathematics, and let's get started. So today we are gonna be looking at logic gates, and of course there are 6 types of logic gates, and we are gonna be discussing them all. So we are gonna be starting with the NOT gate, and as you can see on your screen, I have drawn for you how it's actually drawn. So for NOT, we just have one input, which is actually A, and of course the symbol is actually looks like this, and you don't want to forget the oval kind of things on the front. It actually since there is another gate which is actually represented with no so on NOT gate, the statement it actually follows is that the output X, which is here, is actually true, and before we continue, what you want to know, not by true, it actually means it's actually 1. True means 1, and false is actually represented by 0. So it says output X is true, which is this. If input A, which is this, is false, which means false, I have said, it actually means the 0, and true means a 1. So what it simply just means is that this X is actually 1 if A is actually 0. So we have a truth table in which we draw when it comes to logic gates, and you can see truth table for X is equals to not A, which means not A just means if A is not true. So we have input, if input A is 0, which means input A is false, then the output X is true, which means output X is 1. But if input A is 1, which means input A is true, and then it means the output X is actually false, which means it's 0. So that's for the first gate, the NOT gate. Let's go to the second one, which is the AND gate, and of course the AND gate is actually drawn like this. It actually represented by something that looks like a half a circle, and as you can see, it actually follows the following statement, where it states that the output X is true, which this is the output X, and by true I have told you that it means it's 1. The output X is true if input A and B are both true, which means the output X is just true or is 1 when input A and B are both ones, both true. So when it comes to here, of course 0 means A is false, and 0 is for B is false, which means the output X is not true, which means it's 0. 0 for A, which means it's not true, and for B 1 is true, but of course we have said output X can only be true if A and B are both true, which means if A and B are both ones, which means the output X here will be 0. Here A is true, but B is false, which means the output X is false. And now for the other, where A is true by 1 and B is true, so it also means A and B are true, giving an output X as true as well. So we want to go to the third gate, which is the OR gate. So here we just draw the represented by this figure, where you can see it looks like a front arrow, and it actually follows the following statement, where we say the output X is true, which means it's 1, if input A or B is true, which means either A or B. If either A or B, one of them is true, then output X becomes true, which means it becomes 1. So for this statement, on this table where is 0 and B is 0, neither is true, which means the output X becomes a 0. So in the second case, we have we have A being 0, which means it's false, but B is true, and since it's A or B, anyone is true, then the X becomes true. We have the output X as 1. As well as in this situation where we have A as true, but B is false, which means output X becomes true. So because we are dealing with neither, where we have A as true and B also is true, so either one of them is true, so we just have output X is true as well, which means it's 1. So we want to go to the fourth gate, that's the OR gate, you want to mark. So on the fourth gate, we have the NAND gate, where you gonna note it's actually drawn like this, and you're gonna note it has a similarity with the AND gate, but as I have said, the AND gate didn't have this over, but the NAND gate does have this over. So it actually follows the following statement, where we say the output X is actually true, which means it's 1 if A and B are not both trues. So it's only when A and B are both not true, which means are both zeros, when the output X is actually true. So in this situation, we have output A not being true and output B not being true, which means the output X is actually true, and here we have input A being not true and input B of course being true, but we have to, in order for the output X to be true, they both have to be false, but in this situation B is true, which means we have output X is not true, and on this we have A is true and B is not true, which means we just have output X is not true, which means it's 0. In this situation they are both true, but the question asks whenever output X becomes true whenever the A and B are not true. So since they are both true, then output X becomes not true, which means it's 0. So on the fifth gate, we want to look at the NOR gate. Of course, you're going to note there is a similarity with the OR gate, but I have said on NOR gate we didn't have this over, but on the NOR gate we have this over. Kindly note whenever you are drawing the structure to always know the difference, because the examiner will actually check this in order to know you have differentiated between the OR gate and the NOR gate. So it actually follows the following statement, where we say the output X, which is this, is actually true if input A, which is here, or NOR input B are not both true. That I know the statement may sound a little bit confusing, but what it just simply means is that output X is true if only B and A are not both true. So we wanna come here draw. So we have if input A is not true and input B is not true, which means either of them is true, we have output X as 1, which means it's true. Here we have input A not being true, but input B is true, which means either of one of them, which is B, is actually true, so we have the output X is not true. Here we have A as true and B as not true, which gives us as output not being true. Here they are both true, and we just have to have none of them not being true in order to have output X as true. So we just have output X not being true, which means it's a 0. So we want to look at our sixth and the last gate, which is SOR gate. So it's actually represented by this, mainly this line below the OR gate. So we have SOR gate. It actually follows the following statement. So when reading the statement, you might get confused, but I will explain to the fullest. So it actually says the output x is true here if input A or not input B or not input A or input B is true. So what it is just simply means the confusion. You want to read it like this, maybe you understand. The output x is true if input B or not, if input A or not input B, or input B or not input A is true. So what it just simply means in simple words is that the output x is true where if A is true and B is not true, or if B is true and A is not true. So it just simply means for output x to be true, either of them has to be true. So it could be B which is true and A is not true. So the output x becomes true. Whenever either of them is true, then the output becomes true. But whenever they are both false, then the output becomes not true. So in order for the output to be true, of course, either of them has to be true. And when we mean either of them, we mean that in the situation like this where they are both true, then they actually the output becomes not true, which means it's zero, because either of them has to be false in order for the other to be true, so that the output can be true. So in this situation we have 0 is not true for input A, and B for 0 is not true, which means neither of them is true, and we have we have the output is not true. In this situation, A is not true and B is actually true. So it actually follows this statement, not A, which means not A is true, but B is actually true. So then the output x becomes a true. On the other situation, we have A being true and of course not B being false. So we have that B is false and A is true, so the output becomes true. On this situation, we have A is true and also B is true, which means both of them are true. The notes do not apply, so it just becomes the output as not true. Thank you. I hope you have understood, and I would actually urge you to practice more on the gates, and I would also recommend another video which is the logic gates and the appliance. The link will be in the description, where we have actually they are called the logic gates and the networks, where we have tackled questions. The kind of question actually contains great marks, so I would greatly recommend it. And also don't forget to subscribe and hit the bell icon so that you may get notified whenever we post more content. Thank you.